started because I have a few slides to finish up about WD1 before Professor Yassin starts on the Milestone 2 overview. And I just wanted to finish up a few things around supporting some of the claims you make in WD1 with scholarly sources. So last class we talked a little bit about how in computer engineering you were probably going to see the more credible, more current, and more important articles showing up at conferences as opposed to journals. So that's something we wanted to kind of point out very quickly, just because of the pace of the field and the way that the field works. Now, one of the things that we emphasized when we were talking about this was that scholarly does not necessarily mean credible. We saw a couple of examples where we thought a pretty credible source you could use for your WD1 was not necessarily scholarly, right? You are required to find 2 scholarly articles for that, but that doesn't restrict you from using other sources, okay? So let's talk very quickly about what we mean by credible. And I think this is review from APS 111, 112, so I won't go through it very much, but there's a lot of factors that go into determining whether a source is credible or not. And you're the one that has to make that assessment, right? Could be relevance, could be date of publication, could be the author or authoring organization, citations, who it's been cited by, lots of things. And you've probably already seen this CRAP test that, or acronym from APS 111, 112. So I just wanted to say that there's really no single metric for credibility here, and that you need to consider multiple factors and the context of use to determine or not whether or not you should be using a source for a particular purpose and in a particular context in your document, okay? Now there is something I will point you to, which is this WD1 graphics proposal research guide that is linked on Quirkus. You have other resources to look at too. You have engineering librarians, you have your CIs, you have the opportunity to use Piazza posts to ask some questions. Somebody has already done that here, so that's good. A couple hints I just want to kind of throw out there is to use Boolean searches, right? Those are really important in terms of your research skills, just to know what to include and what to exclude in those search terms. But then to also to think about the field of UX, user experience and user interface, because that is an entire field of study that you can draw from, okay? So make sure that you're aware of that. I want to talk very quickly about how you're going to use these scholarly resources to support things that you're going to say in the state-of-the-art review, in your proposal, and also in your testing, right? Remember we talked about it serving as evidence to justify your analysis of your GIS and also of your design being usable and responsive. So you can see in the sample here that we have a result from research being mentioned and cited here, and then that used to assess the usability of one of the GISs in your state-of-the-art review. Okay, so there's one example of how you would use a scholarly resource in your state-of-the-art review. Okay, and you can see how you're playing on kind of mentioning this data and this evidence that you found in the source, and then using that to apply it to your own analysis of what you've chosen as a GIS, okay? You'll probably see that in your proposal as well. So here we have a proposal for a low contrast map interface that is backed by a study that says that users retain more correct information when reading maps with lower contrast versus higher contrast, okay? You're kind of building these scholarly resources to support the claims that you're making in both of these sections, okay? Finally, I want to talk about how you want to use this in your testing plan, okay? This part of the WD1 is probably the most challenging. It's the easiest to use scholarly sources from because they're the ones that can help you develop what you would want to actually test for. So here's some examples here, okay? The first one is dividing 50 test subjects into 25 experts and non-experts in order to understand the experience of both new and experienced users with your GIS. Or it's just to specify what your targeted response times are. Now, a couple things about your testing section. This is a test that a scholarly source might write. They might have the time to have 50 people look at these, look at their UX and actually determine whether or not they can use it effectively or not. Are you going to be able to run that same test? No, you're probably not going to be able to have the time to do that. So you would probably want to cut the number, number of test subjects, or kind of change your test around to make it a little bit simpler and something you can actually do. But something like this, in terms of looking at a targeted response time, that is something that you could maybe code very quickly and get quantitative results for. And so you want to think about, in your testing plan, finding scholarly sources to help and define those metrics for usability and responsiveness, okay, and finding ways to test it, but also to make sure that what methods you're suggesting are actually practical methods, right? You don't have to do anything nearly as extensive or propose anything nearly as extensive as what's in the first example. Okay, so now we have a good sense, I hope, of WD1. You'll have conversations about it with your CI this week, and then hopefully a little bit the week after as well. And now you know how to build in those scholarly resources to help support the claims that you're going to be making. Okay, thanks.
Thank you. Okay, morning everyone. So how was Milestone 1? Any feedback? Was it easy, difficult, average? Okay, that's good. So for me now the real fun begins with Milestone 2. Milestone 2 is all about visualization. We will try to interactively visualize all of the data that we've used in Milestone 1, from intersections, points of interest, lakes, rivers, etc. It's more of an open-ended milestone. That means the specs are a bit loose. We will, we give you the initial requirements, but we will leave it to you to basically fill in what is needed or fill in the details. So we will teach you the basics of graphics. We've taught you the basics of data, like the data structures that you're going to use, the OpenStreetMap data, how it looks like, and how to query any questions you have from it. Okay. For the best solution, again, we will give you like some initial requirements for the visualization. For the best solution, you will end up creating new extra features, come up with your own ideas, and polish the map as much as possible. So it's a bit different from most labs. Most labs, basically, you apply what you learn in the lectures. In this milestone, you are more of you have more of a design perspective. So you will go beyond what you've been taught in the class. So this is all going to be new. Has anyone used graphics before or like tried to develop applications with graphics before? Yeah, a few. Okay. So if it's new to you, that's fine. It's going to stretch you a little bit. So it's not going to be like, you're not going to say that, oh, this is easy and it's boring. So remember this graph from lecture 1. So ideally, you want to be in the middle section here. It's gonna stretch you a little bit. You're gonna say that this is all new to me. I need to learn a lot of new stuff, but that's fine. You probably won't be in this area where you're saying, oh, this is very easy, this is very boring, I'm not learning anything new. But at the same time, we don't want you to be here. So we don't want you to like try to perfect everything. Perfection is not possible. We know that you have other courses, so don't get too stressed about, oh, is this a good idea or it's not. Ask us, ask your TA or CI whether this is like a good feature to add or not to the map. My recommendation is for you to start early. It has a bit of a learning curve in this milestone, especially with the graphics part. So you have around 3 weeks from now to finish it. Get something working. Don't try to implement everything that you've envisioned from the beginning. It's usually hard to do that, and you would probably run into a lot of issues. So get something working. Let's say that, oh, I'm going to just visualize the intersections right now and see how things look like. See how smooth it is, and then try to polish it a little bit more. Okay, and then once you're done with the basics, try to improve and come up with your own ideas. But again, don't try to be perfect. It's really hard to do that, and you don't want to just work on this course and ignore other courses. Okay, so what are we doing for Milestone 2? Remember, in Milestone 1, we gave you these two APIs, the Streets Database API and OSM Database API. In the Streets Database API, which is the higher level API, this is more structured, it's less abstract, and it queries all of the information that you need to visualize in Milestone 2, from intersections, from streets, street segments, points of interest, lakes, rivers, etc. You will So the basic requirements will tell you to visualize all of these things, and then for the OSM database API, you can use it in order to implement some of the features or ideas that you might have. So for example, some people try to visualize, for example, subway lines. Subway lines do not exist in the in the LibStreet database API, so you will need to go to the OSM data. Okay, so yeah, the requirement is to use layer 2. Optionally, you can use layer 1. We're going to talk about some of these ideas that we can visualize. For example, you can visualize bike lanes, you can visualize train routes, etc. All of these exist in the OSM database, but you will have to do a little bit more work in order to try to find the data that you want to visualize. There is a quick start guide on the OSM database API from Milestone 1. So if you're interested into how to use it, if you haven't used it yet, you can go ahead and look at it. Okay, so what are the basic requirements on Milestone 2? As I said, you need to visualize all of the basic data: intersections, features, points of interest, lakes, rivers, streams, etc. These all exist in layer 2. You need to be able to, for example, click on an intersection for extra data. So like I'm gonna click on this intersection and it's gonna give me its name or its latitude, longitude, etc. Like some information about the intersection. We want to be able to find an intersection by name. So we're going to put in the search bar or whatever button, like you're gonna create a button, for example. So to be able to search, we're gonna enter the name and it will basically take us or point us to the intersection that we specified, or like just add a pin on that intersection. We want to be able to load any map without recompilation. What does this mean? So in Milestone 1, I think most of you just used Toronto map, and in the private test, we're gonna test on your code on other maps. All of these maps exist in the public ECE297 directory. We want to be able to visualize any of these maps in the public directory, but without recompilation, meaning we don't want to rehack the code, for example, or just like recompile the code saying that I'm going to specify the file name for New York, for example. No, we want the ability, whether from the command line or like you can add your own button to list all of the maps that are available. And then once the user chooses one of these maps, it should open that map without crashing, without recompiling. Okay. Your graphics should be fast and interactive, means we don't want it, like it's probably difficult to have it very smooth or as smooth as possible, like 60 frames per second. Most teams want to achieve that, but we don't need it to be like so like that it's annoying to the user. So we need it to be a little bit smooth, a little bit fast, responsive that to any of the, when we ask for any of the features from the map. But at the same time, and this is a challenge in Milestone 2, we want to be able to visualize all of the details. But it's gonna be up to you to choose at which level you're going to visualize more data or more information. If you visualize all of the intersections, all of the names, etc., at every single level or every single zoom level, for example, it's gonna be very cluttery, it's gonna be annoying to the user to use, and it's not gonna be visually appealing. At the same time, it's going to be very slow because you are visualizing everything at the same time all the time. So it's up to you to figure out when to visualize certain data and when not to. The important thing is do not hard code anything. So we will test your code on all the maps. Your TA during the demo will ask you, for example, to open any of the maps available in the public directory. So don't try to hard code things. We don't have too many tests right in this milestone. It's all about the TA mark, but we have like one test to run Valgrind and make sure that different maps open. Okay. Some of the code will go under main.cpp, and this is where the main function that you're going to implement. We haven't implemented that yet. In the skeleton code that we're gonna give you in milestone 2, there is just like a small piece of code where it tells you that this is where you're going to run your map. But most of your code will still go under the libstreetmap source directory. Why is that? Because again, remember from the previous lecture, we talked, or 2 lectures ago, we talked about that we are creating a library, a static library that can be invoked from both the main executable and the testing executable if we needed to. So the bulk of the code, again, is going to go under the libstreetmap source, and some of the code to run your executable and like your main function will go under main.cpp. Any questions so far? All clear? Good. Okay, so grading. The milestone is worth 16% of your grade. It's, I think, the largest milestone in this course. It's divided into several aspects that we're going to look for. The rubric is posted on Quirkis, feel free to look at it. But mainly, 2 of the marks will be for code style and project management, similar to what you did in milestone 1. So make sure that you're following the same convention as milestone 1 if you've developed your own convention for code style, for example. Make sure that you're still using the wiki, updating the task breakdown on the wiki, who is doing what, tracking deadlines, etc. Because again, the TA and the CI will look for these at the end of the milestone. Okay. For the basic features that we just talked about, these are all worth 5 marks. So basically visualizing all of the street database API. For the responsiveness and aesthetics, this is worth 4 marks. So again, here, this is a bit of a challenge. You want to make sure that we are visualizing all the details, but at the same time, like the map is visually appealing, the map is responsive, it's a bit fast to the user, it's not annoying, it's not cluttery, etc. For example, one of the main challenges here is how to choose to display the street names. The street names, if you zoom in, for example, some of the street names will disappear. Do we need to show these names again or not? So all of these decisions that you're going to do will affect your responsiveness. So yeah, you will have to think a little bit ahead or upfront to make sure to have a certain idea in mind on how you're going to do things. Remember, this is an agile development, so you just need to have an initial idea, come up with a prototype, and then try to polish it iteratively. Okay, and the final 5 marks will be on extra features. So these extra features are basically ideas that you will come up with, or we will give you some ideas that you can implement. And they will be graded based on difficulty. So some of these features, we know that they are a little bit difficult. They are worth more marks than easy ones. If you look at the rubric, there is also a sheet where it lists a lot of ideas and how difficult we think they are and what mark they are worth for. So in order to try to achieve a full mark on this milestone, you need to achieve at least 5 marks. And these are usually around like 2 difficult features. So some of these features that you can implement is, as I said before, display extra data from the layer 1 API, from OSM database API, such as bike lanes, subway lines, train routes, etc. You can enhance, you can add more clickable features, streets, parks. So in this milestone, we ask you to at least be able to click on intersections, but you can extend that to any of the entities we have, streets, parks, rivers, streams, whatever, and you can click on them, give you more data about them, like are these, for example, touristy, are these, any information that you can add to them. You can also add data from the web. We have a quick start guide on how to use this library called libcurl. And it basically tries to download data in real time while you're running your application and visualize this data. Some of this data is like, for example, is there any traffic at certain area in the city? What is the weather looking like in this city, etc. We have a quick start guide that lists also some of the websites that have data that might be interesting to you. But again, feel free to extend beyond that and try to find your own data. But the libcurl will help you to use to fetch any of these data in real time. You can also, so the graphics library that we provide you is called ECE297. ECE297 is like an API that we're going to talk about in a little bit. It gives you the ability to draw polygons, add buttons, etc. But you can, this library is built on top of a more advanced and wider library called GTK. And we give you a quick start guide. If it's interesting to you, you can go directly to the GTK library, modify certain things in the window, so you can have, you can make any edits you want. So for example, you can add a search bar, like an auto-completion search bar, dialog boxes, etc. These are not existent in the ECE297, but they are available in the GTK. So if you want to polish your map more, and these are considered part of the extra features, you can do so with the GTK library. And finally, you can add your own ideas. Some people might think, oh, I'm gonna, like now everyone is talking about like ChatGPT and LLMs. Maybe I can hook my map to an API where I can launch a machine learning model to give me information about a certain city I'm visualizing. Things like that, all of these are ideas that you can come up with, but you will need to do a little bit more research on how to implement them because we do not have quick start guide for these. If you think you have an idea that might be useful or might be beneficial, ask your TA or ask me or your CI on whether this feature, is it useful and how difficult it is to implement. If it is difficult, might be worth a lot of marks. If it's not, we'll tell you that, oh, you can do something better. Okay, so I'm going to go like 5 minutes over our solution. It's not a very good map. It's not like the best map that you will see. It has some of the like basic requirements that we want you to implement and some extra features, but it's not as responsive as it can be. Okay, so here we are visualizing Toronto, and you can see it's not as responsive, it doesn't load quickly, but. Okay, so you can see if you've been to Google Maps, which I assume you've been to, this is Toronto, it looks like Toronto, right? We have, so this is built again on top of the ECE297 graphics library. There is a zoom in button where you can zoom in into to visualize more details. So as we zoom in, you can see now we added a little bit more details. We visualize more street blocks, more buildings, etc. And here we have details, I think, sorry, the names off. So if you press on the names on here, it will start visualizing street names. But so for example, this is not a good map because we are not seeing any details yet. We need to zoom in a little bit more. Are we going to see details yet? Now we can see that there is a street name here, and it's very small. We cannot even see it. So again, we haven't focused in this in our golden solution to create the best map. Our golden solution is mainly to create tests that you can use in your exercises. But we just wanted to show you some like what we mean by the basic requirements. And to see how not good it is, if you zoom a little bit more, the street name is gone. We cannot see it anymore. So these are some of the decisions and challenges I'm telling you about that you will need to think about upfront in order to understand like at which zoom level you are going to visualize certain data, how often you're going to visualize, for example, street names, etc. Right now we have the POIs on, so it should show me some of the points of interest. Let me see. Yeah, so if you see here in yellow, you can see like some of these are points of interest with names on them, but again, the font is small, I can't even read it, so it's not the best, okay? Oops. So I'm going to go to zoom fit again to show to the top level, and some of the extra features that we have is to show here the subways. So these are the subway lines of Toronto. If you zoom in, you can see that, yeah, these are like line 1, line 2, etc. All of this is available from the OSM database API, sorry. The rest are not related to this milestone. They are basically for future milestones that we have. Okay, so as I said, we need the ability to load the map. Also, like you can see here, some of these warnings are related to the ECE297 library, so you don't have to worry about them, but like if there are warnings that are related to your code, then you have to worry about these because these are part of the code style and whether you make sure that you don't have any warnings. So we said that we want to load any map without recompilation. So we added this ability in our mapper, and if you type .h, it's gonna tell me, give me a help error information. And here we can provide a map argument. So if we go, oops. So you can see here, these are all the maps that you want to visualize, at least the streets.bin files. And let's visualize, for example, New York. Okay. So here is the New York map. Again, it has all of the informations we need, basic requirements at least. For example, you can click on the subways, it should show us. Yeah, you can see that it's not as responsive, or it's not very responsive at all. So yeah, these are the subway lines, for example. So one way to do this, again, to visualize any map is to give the user an option to do it in the command line. But if you want like more usable map, I would do it from the visualization directly, like maybe add a button or add a list of all of the maps that are available in order for the user to choose from and just close your current map and visualize the other one. Okay, so any questions so far? The tutorials this week will focus on, we'll have a lot of demos on Milestone 2, and we'll focus on some of the functionalities that you will probably need to visualize different things. So I really recommend attending these. Okay, so we talked about extra features, and we talked about that certain extra features are worth more marks than others. So let's talk about, is this, for example, a good extra feature? Let's say that I want to have a feature that changes the color scheme of my map. For example, a pinkify button. If I click on the map, on that button, it will make the map more pink. Is this a good, do you think is this a good feature or not? Yeah, I can see a lot of heads nodding. So basically, it's not useful. Why do I need to pinkify the map? That's one thing. The second thing, it's very easy to implement. It's just basically changing the background color of the map, and it will just overload the previous color. Okay, so this is probably worth less than 0.5 marks. So if you want to implement a lot of these features, you might end up getting the 5, but you're going to do a lot of work that you might have done to a better job into like just putting the effort into like the difficult or medium level features. So again, the difficulty matters. Okay, so how does Milestone 2 relate to the written document 1 that Professor Chung was talking about? So written document 1 is all about making a proposal and doing a background research that relates to geographical information systems or GIS systems and how to display this info. And this is a good thing to do in any project, not just in this project. So usually whenever I start my own project or like when I was doing my PhD, we always start with doing some background research, seeing what people have done out there, like seeing the approaches that they have taken, whether they are good or bad. This is especially important because sometimes a lot of people like spend a year or two coming up with their own solution and trying to implement it. And then when they come out to write their final report or like their thesis, they need to do more background research because there should be a background chapter in that thesis. And then they find out that, this approach has already been thought about previously, and there were a lot of negatives about it. So now you need to justify why is your implementation a positive while other people have said it's already not working or like not good for the thing that you're working on. So in any project, it's very good to have this approach to first of all do your background research. And this is why we are giving you written document 1 along with milestone 2. We need you to do some research on some of the challenges that you will encounter in milestone 2. So for example, how to make your map responsive, how to while at the same time visualizing all the details that you need to visualize. Okay, so this thing gives you the ability to list several ideas and try to quantify or look at the pros and cons of each approach and then decide what you want to go ahead with. Okay. So once you do the survey landscape and find your research, you make a plan. What will you do? And how will you use or how will your solution differ from others or from whatever solutions you found in your research? And then you will try and measure the success of your ideas or quantify how good or whether they need more work or not. Okay, so as I said, never skip this step. It's very important. And although the deadlines kind of WD1 and milestone 2 coincide with each other, but try to have a head start on like WD1 and see what ideas out there, because at the same time you will use them to implement milestone 2. Okay, so I'm going to give you like 2-3 minutes to think with your colleagues on what is our measure of success, or how are we going to test whether a map is useful or is usable, and how we're going to test its responsiveness, or what do we mean by responsiveness in general. So you will end up asking yourself that question when you implement the features in milestone 2. So we want to give you, we want you to think about how we're going to do this. Is there a certain criteria that we need to meet, for example, or is this all subjective? And yeah, it's up to you to decide. We want you to think about it, and let's discuss in a minute or two. Okay, so anyone wants to weigh in or like give me a suggestion on how we're going to test our usability and responsiveness? Yes, A07.
One usability test was, we bet there's some scholarly resource out there talking about how readable text should be at different distances from the screen. And you
Okay.
can test that at different zoom levels in your map.
Okay, but how are we going to quantify this? Like, are we going to say this is good or?
We're going to have to research some academic resource that gives actual measurements of how far you should be from the screen and still be able to read a piece of text or what's like a minimum font size.
Okay, yeah, so one of the features that we're going to implement is how to visualize all of these street names and all of these details. So your friend suggested here, basically, we're going to rely on the background research that we do to see whether there are any measurement, like certain criteria on how far we are from the screen, and are we still able to see that name, for example. And at which level we're going to, do we need to zoom in more to visualize this more data, or is this zoom level is good enough? So yeah, that's a good suggestion. B10.
This might be out of the scope of the course.
Sorry, just a second. Can you speak on the mic?
This might be out of the scope of the course, but say I'm loading a map for a city in a different country where they use a different alphabet.
Okay,
If I'm out on the street and the street names and everything might not necessarily be in English.
right?
Even if I don't know the language, I'd be able to match characters. So maybe it's on like the extra features side, but the map could have like street names or like point of interest names in other languages.
Yeah, sorry. So yeah, you basically want your map to be usable to any user, not just like English-speaking users. So we want to make sure that if someone is visualizing my map for a different city where the names, for example, are not in English, are we still able to do that? This, as you said, falls under the extra features. We do not require to do that in this course, but again, this is part of the usability and the aesthetics of your map. So definitely this is something to think about, and it will help your map be usable. Anything else? What about responsiveness? What do we mean by responsiveness, and how do we measure it? Anyone has any idea? Yes, B10 again. Go ahead.
I guess like the data for some cities is going to be like vastly larger than other cities, so we should still be like pretty fast. So we should call them like the same fast functions that we wrote in M.
Okay, so but how do you quantify fast? Like what do you mean by fast?
Maybe we could set like a reasonable time. We could benchmark off of like Apple Maps, Google Maps, or whatever, and then based off that we could set a benchmark.
Yeah, okay. So for example, cities like Tokyo, they contain much larger data than Toronto, and it's going to be very slow to load. So your friend here suggested that we can benchmark and see how other maps look like in terms of like loading these maps, and we can set a threshold for ourselves to try and match that threshold and like to load that map. One way to do this, and I think we've used a little bit of it in the performance test in Milestone 1, is to use timers. Tutorial 2 is going to introduce, and I think in the future tutorial, we're going to teach you how to profile functions or portions of the code that you are writing in order to see how long they are taking in real time. And based on that, you can quantify whether this is good speed or not. So yeah, responsiveness is very important. And it's sometimes hard to quantify. Another way to think about this is to, for example, ask your peers or your family to try and test out your design and get feedback from them, whether this is good or bad. Is it usable? Is it quite fast, or is it annoying to use? So all of this feedback will help you try and reiterate on your code. This is similar to what we talked about in the previous lecture about what Google does in terms of continuous deployment, where they release their new products to only 2% of the market and try to get feedback from whoever the product is released to. And if it is good enough, they will release it to the wider community. If it is not, they will pull it back and try to polish it and improve it. So again, so as your friend suggested here, to try and make the map usable by a wider community, think about certain features that will help others for example, displaying names of different cities. Try to ask your colleagues or your family members to test out your map before deploying it, in this case, before submitting it. Is this a good, is it usable? Is it annoying to use? Is it cluttery? Is it responsive? And to measure responsiveness, again, we will use some timers in the code to quantify how long certain portions of the code are taking and see whether they are good enough and compare them to benchmarks from Google Maps, Apple Maps, etc. Yeah, all of these are good ideas, and you will end up using one or two of these ideas when you are developing Milestone 2. Okay, so I alluded a little bit to what timer functions are. Again, we will talk about it in the tutorial, the next tutorial, so the week after reading week. But the idea is to, there are certain libraries in C++ that allow you to do that. One of them is called Chrono. And the idea is to basically put a timer and try to find the current time right before the portion of the code that you want to measure, and a timer right after that code. So here you can see that there is a start time, and so after the start time, you will do a lot of drawing. For example, I'm going to draw, let's say, all the intersections. I want to see how long drawing my intersections is taking, because we don't have performance tests for these, so you will try and profile these things yourself. And then after that code, you will say that the current time or the end time is this, and then you find the difference between these two and print it out. And this will give you how long it took in real time, and you will basically see yourself whether this is good or bad. So there are a lot of other methods to profile codes. Sometimes it's not possible to put these timers right before and after every single piece of code. There are things called profilers. We use them widely in the industry, especially during development phase. So in tutorial 7, we will introduce you to what profiling is and how to, it even gives you like a lot of figures on kind of heat maps where things are taking a lot of time and things are like, okay, they are not taking as much time. It will give you a percentage of which code is taking how much time of the total runtime. So all of these things are useful to measure the success of your responsiveness. Okay, so we talked about Milestone 2, how it relates to WD1 and what you need to do. Let's dive into a little bit into the graphics, because this is new to you, and how do we develop graphics in software. So I think you've used graphics a little bit in, I think, ECE241, where you use the VGA. Are you still using that, by the way? Yeah, so in the VGA, what you do is try to write the pixels directly into the hardware, and this will visualize it on the screen. Now, the problem with do you think that's a good idea to follow in even software? Right, it's not. Why is that? First of all, it's very low level. You're writing the pixels directly to the hardware, so it's going to be a lot of work. Software engineers are very lazy. We don't want to do that. So second thing is that each hardware is different. So this is going to be different for each platform. So for example, if you're using a Windows or if you're using a Linux, all of these are different, and their way of interacting with the underlying hardware is different. Or using a printer, for example, to print on a piece of paper. Okay? So the third thing is many programs share screens, and the operation system, for example, Linux or Windows, won't let you to actually edit the pixels on the underlying hardware to protect the security of all the users that are using the same server. So this is not possible. So the solution to this is what we call graphics APIs. These application programming interface, similar to what, for example, Street Database API or SAM Database API, all of these are interfaces that the user can use. In the background, some developer came and wrote a lot of implementation details that will query certain things for you. So in graphics, it's similar. We have an API that we have developed, for example, and under the hood, it does a lot of complicated things to deal with, to interact with the underlying hardware. From the user's perspective, all he wants to do, or they want to do, is to just query certain things from this API to draw the things they want. So the benefits of using application programming interface are It's higher level. We're not directly writing to the hardware, so it's easier to implement. It can target different hardwares, so because it's abstract, it doesn't need to know what hardware you are using. And the operating system is trusted. Now, in the background, whoever developed that API will have to write more code to specific for each operating system. So one for Windows, one for Linux, etc. But once this is only done once, and once that is done, the user can query the same function whether he's working on any operating system. And in this course, we do this. We have this library, as I mentioned before, called EZGL or EZGL. And it's very simple. It's cross-platform. You can use it on multiple operating systems. In this course, we mainly use the UG machines, which are based on Linux Debian. Okay, and all of you will be using this layer. This layer is built on top of another API, a lower-level API called the GTK, similar to what we do with the street database, which is also a more higher level than the OSM database. The GTK is a wider API. It has more features. It has more things you can use. And again, we have a quick start guide on how to use it if you want to use it for your extra features. And on top of that, this GTK is also built on top of another library called Cairo and X11, and these libraries are the ones responsible of writing the pixels to the actual hardware. So yeah, I hope this gives you an idea. When you do ECE297 init 2 for this milestone, we will give you the EZGL. We will add the EZGL library to your code. It's going to be under a directory called EZGL. And to use it, the main two files that you need to include are application.hpp and graphics.hpp. There is a quick start guide on Quarkus on how to use this library, so feel free to play a little bit with the code before you start on the actual milestone in order to just get your hands dirty with how things work. The application.hpp is mainly responsible about creating the window setup, how it looks like, and what buttons you're going to add to it. The graphics.hpp is the one that you're going to use mainly to draw and visualize. So you can draw points, you can draw polygons, you can draw lines, you can draw images, etc. So whenever you want to use anything from the EZGL, you will need to include these two files in any of the, oops. Yeah. Okay, so what are the types of graphic functions that we provide you? There are certain things to set up the graphics window, mainly in the application.hpp, and you will do this only once, right at the start of your program. This will be basically, you will tell the program, oh, draw me a canvas where I'm going to add all of my work on it. So it's kind of like a paint board that you're going to use, okay? Then you will set your drawing attributes, and this you will do many times. So in this, by attributes, we mean this is where you're going to use the color that you want to draw with, the thickness, what kind of pen, etc. Then there are certain functions that let you draw primitives, and these primitives are like lines, arcs, polygons, rectangles, images, etc. And all of these are going to be done many times. And there are certain functions that you're going to develop to respond to user inputs. So for example, if the user clicks on the mouse, we need some function that, because the graphics library doesn't know what to do with it, you will develop your own function to tell it, okay, once you click on the mouse, I'm going to find, for example, my closest intersection to that mouse click, and I'll display some information about it. Okay, so these functions basically redraw the window from scratch with the additional information that you did. For example, even to zoom in or like use a scroll bar, these are all redrawing methods. Okay, so how does the EZGL library respond to user input? So let's say you have your program called myprog.exe. At the beginning, you're going to draw your canvas, you're going to draw all of your arcs, lines, etc. through the EZGL library, and then you will visualize things. Now let's say that the user resizes the window, or he clicks a mouse button. The hardware